Hello and welcome to the session. In today's session, I'll be discussing some of the basic points and some of the basic issues relating to various courses of second trimester of ADIT. To begin with, what do we think is the basic objective of the second trimester of ADIT? Well, if you remember, in the first trimester, in a similar kind of session, what I have stated that the first objective of the first trimester are to develop the environment and the paradigms for problem solving using computers. That means in the first trimester you were mainly looking towards the basic issues of problem solving and paradigms. For example, you covered the topics of data structure. We covered the topics relating to object-oriented programming languages, which includes C++ and Visual Basic. And we also covered some of the basic facets of C programming language, which were involved or enveloped into the data structure concept. And in addition, we also looked into some of the basic concepts of system software in the form of an operating system, which we emphasized that you should be dealing with Unix operating system to a certain extent. However, in this particular semester, whatever we have acquired earlier probably is to be enhanced further. And that is what is going to give us the power to go through this particular program. So let us see what is the basic objective of the second trimester. Well, the basic objective of second trimester is to take the environment of problem solving to systems with the help of concepts of COM, networks, database management system, and software engineering. You have done some of the basic things in software engineering earlier, but in this particular semester we will be going further in the concept of software engineering. Now let us discuss, if these are the things which we have to do, what are the courses which we will be taking or you will be taking in this particular trimester? Well, you have 4 courses in this particular trimester. The first one is component programming. Second one is data communication and networking, relational database systems, in fact database management system, and advanced topic in software engineering. Our objective will be that we go through these subjects one by one. In fact, the kind of scheduling which we have proposed to you in the starter kit suggests that you go through chapter 1 first, that is CST 201 component programming first, go to networking, go to RDBMS, and finally you go to the software engineering. Now the basic reasoning, now you will find some of the concepts which you will be dealing in component programming involved some of the basic issues related to networking or some of the things in, let's say, databases. However, those basic aspects you can always foresee beforehand. And the objective of this particular session is to make you aware about those kinds of things in this particular session. But what is the first course, the component programming? And what are the basic objectives we have perceived for this particular course? Well, the component programming module or the component programming course has been given for imparting to introduce the basic issues relating to component object model, which is called COM, distributed component object model, DCOM, almost the same kind of technology, to introduce the concept of COM objects, to define the basic issues relating to persistence, and to define the issues relating to security in COM, DCOM. What you will find in this particular course, the basic issues are utilizing a technology to design something called reusable classes, or maybe designing something which can be reutilized in some by any other package, in spite of whether you have used it or designed it using Visual Basic or Visual C++. So here is a technology which in fact is being offered by Microsoft, which basically is trying to extend the technology of object-oriented programming and object-oriented system, which we have learned in our previous semester, to actual industrial implementation. In fact, what you are going to find that these technologies are more from the training from the point of view of technical aspect, rather than there will be less number of theoretical aspect as far as this technology is concerned. You will find certain problems in that particular aspect because the technology whenever is changing, and when it is changing very, very fast, you really have to keep abreast with it. And you once again will hear COM and DCOM, and additional concepts have come into this kind of thing in the form of .NET technologies, or maybe in the form of C# kind of technology. Well, those concepts are basically to be seen under the purview of what technologies you know the best, the object-oriented system. And what you really got to do is extend those kinds of things into the COM and DCOM kind of technologies. The persistence is basically an issue, and security is basically issue when you are dealing with COM objects. So you have to further elaborate, further go into this kind of technology in a slightly more detailed form. What are the basic skills we are expecting you to acquire from this particular course? Well, the basic skills we want you to is to identify and correlate concept and terminology of object-oriented programming to COM or DCOM. You try to attempt a design of simple COM-like classes, implement, use, sample COM-DCOM interfaces. They are very, very standard stuff, and you really have to go through those standard stuff in slightly more details to actually use it. So that's what we expect from you. You might have to use references, you might have to use the study material, whatever additional resources which you can get hold on. This is a very interesting topic and will give you some basic insights of how an object-oriented technology have come to a stage of very good implementation, very good paradigm of implementation. Now, how to obtain those skills? Well, to get those skills, the first basic logic which you must follow with all the courses is assignments should be undertaken individually. References should be explored. Try to refer to more references as the technology have progressed further, as I just defined. Do a bit of class design. Last but not the least, you have to do a lot of practice. You have to struggle. You have to go through the technology. You have to struggle with it. Only then you will be able to actually go into the actual domain of COM and DCOM and use the already existing classes which are there, and maybe in the form of having your own classes designed in the form of DLL objects. Well, some of these concepts you are definitely going to explore in this particular course. We don't predict that you will master COM DCOM in this, but getting a feeler for it is extremely important with the help of this particular course. The second important course which you have to undertake in this particular semester or trimester is data communication and networking. And believe it or not, this particular course, if you do with great skill, can fetch you a very good opportunity if you master it. But if you are unable to master it, even then, you should try to go to whatever extent as far as depth is concerned for this particular technology is concerned. Because the telecommunication technologies, along with the computer technologies, are coming up very fast in the market. In fact, they have very good growth potential. Knowing computer networking and data communication concept is a major asset for a computer professional. But what are the basic objectives of this particular course? Well, to define the fundamental concepts of data communication and networking, to describe the concepts relating to data link layer, and to describe the concepts of network, transport and application layers. I think I got you confused here. I have talked about nothing related to networks. What I have talked about is layers. What are these layers? Well, the layers basically, there is a 7-layer architecture which has been designed by International Standards Organization, and the basic objective of those 7-layered structure of computer networking architecture is to give you a standard for protocol design and implementation. In fact, this is a common way. If you have a very big software to design, break it into components of these kinds. The chances are that at each layer or level, you will have different kinds of people, target group or software designer coming in, and at different level, well-defined interfaces are there. That way, your software it doesn't remain proprietary anymore. Many people can join in, many different kinds of software can be developed. However, keeping the basic standards intact gives a lot of opportunities for software development. And you will find this is one concept because of which Microsoft has come up to the forefront, and Apple Macintosh, because of their proprietary stuff, were to a certain extent were at some of the were not so popular in the context of India also. So what do we have for you in this particular case? Well, the first layer in this particular model which you have to undertake is called the physical layer, or the physical connections to that extent. Well, the physical layer is concerned with transmitting raw bits over a communication channel. So there is a communication channel. How bits will be transmitted through it? Obviously, signals are involved. Basic issue is that a transmitted 1 bit is received as 1 bit, not as a 0 bit. So automatically what you are dealing with is certain kind of voltages. The design issue here deals largely with mechanical, electrical and procedural interfaces and the physical transmission medium. So you are actually dealing with the physical components of a particular network. Probably this is one area where the electronics engineer, maybe the electrical engineer, or maybe the mechanical engineer have a slightly greater role to play. Still, you have some basic role to play. You must basically understand these concepts. But what are the related questions which are basically concerned with the physical layer? Well, these are basically how to represent one electronically, and in today's context, optically too. How many microseconds a bit lasts on a channel? So how many bits you can pack? What is bit rate? What is baud? All those kinds of things. Where transmission may proceed, whether transmission may proceed simultaneously in both directions. You must have seen these kinds of phenomena where in the kind of systems where you are speaking from one end, the other end you simply design a protocol. For example, in police vans you might have find this kind of a thing. You speak something from over here, you stop after saying over, and then the second person speak. On telephone, both the people can speak on the same time, but unfortunately listening might be a problem area, but then both of you can talk at the same time. how the connection is established and terminated at physical level. How are networks connected? The physical aspects of it. So these are some of the basic questions which one has to ask relating to the physical layer. What are the related concepts to the physical layer? Well, some of the major concepts which are related to this particular layer are what is analog and digital signal. Analog, you will find, is a continuously moving signal, the sine wave, whereas digital signal is a jerky kind of signal, jumps in the form of voltages maybe. Transmission medium. Many transmission medium you have heard of in today's context. You might have heard of optical fiber, fiber optic cable, the untwisted pair, unshielded twisted pair, UTP cables, which you get at your home in the form of telephone cables, or in your networks when it is connected from a hub. Multiplexing, same channel, same physical connection, and you are using it for transmitting not one but multiple messages from various people. Simplex, half duplex and full duplex transmission. Simplex in the context, and finally the modem. Simplex when you are dealing in terms of that your transmission is possible only in one direction. Half duplex when in one direction, in fact in both the directions, but one at a time. Full duplex in both the directions simultaneously. And lastly but not the least, modem. Now modem is something, if you have a personal computer at home, you most of the time will be using some device called modem. Why? Your computer is from digital world, whereas your telephone is dealing with analog world. So your digital signal has to be superimposed into an analog world, transmitted and received at the other end, and once again converted to digital signal. Now these are all the issues relating to the physical stuff, right? Now once we move from the physical, what is the next layer? Well, the next layer is called the data link layer. Now what are the objectives of data link layer? The data link layer provides reliable transfer of information across physical link. So it sits onto the physical layer. It sends blocks of data which are called frames with necessary synchronization and error control. Now basically what we are trying to say here is, there is your transmission medium, right? Onto that particular transmission medium, if bits have to go, then there has to be some means through which bits should be moving from one particular place to another place. Some framing system, from structured system are designed so that bits are moving maybe in the form of something which is very commonly used, is called packets. So in the form of packets from one place to final destination, or maybe through one particular computer to another computer which is in between, and maybe from various computers to final destination. However, at all these places, if there is a transmission error in the physical media, that should be immediately checked by this particular data link layer. So from one particular computer, suppose a data has to go to a final computer, let's say that is sitting at fourth or fifth computer. Even the data, if it does not reach properly to the second computer, second, third, fourth, fifth, this is the path suppose, then it should be reported. That is the work of data link layer. So it is basically not concerned with the source and ultimate destination, but it is concerned with intermediate source and intermediate destinations. What are the basic issues relating to this particular layer? The first one and the most important one, identify devices on the network. How will you say this is computer 1, this is computer 2? How will you identify those? Addressing. You might have heard about Ethernet card addresses. That's data link layer addressing. You heard about IP addresses. Those are not data link layer addresses. Control and possibly correct errors. So you just control the errors, and if possible, simply correct. Something called error detection code, error detection and correction codes. Those can be incorporated at this particular point. Control access to network medium. Okay. Now there is maybe a shared medium. What you have in local area networks. There is a shared medium. And if somebody is using that shared medium, the other may have to be controlled. Something of that kind. Maybe something related to multiplexing too. Control data flow. Now what can happen if there are two stations? One can transmit at a very fast pace and other can receive at a very slow rate. In that particular case, the first, if it has lot of information to send, can simply overload the second one with lots of data. Now that's not a good networking thing. So control the flow in that particular sense. So these are the basic issues what is dealt with data link layer. In fact, your physical layer is the topic of your first session, and data link layer is the topic of second session, or second, the second block. The number of sessions have already been given for each topic into your starter kit. The third layer is the network layer, where your internet protocol and IP addresses also resides in a similar kind of layer. Now what this network layer is doing what are the objectives? Well, the network layer is basically for controlling the operation of communication network, which include all the intermediate nodes in the network, all the intermediate computers which are part of the computer subnet or computer network. It is concerned with how the data packets are routed from source to destination through various intermediate nodes in between. It provides independence from data transmission and switching technologies. In fact, this particular third point is for the higher layers. The higher is the layer, the switching technologies, like how exactly the data is flowing in the form of from one to another, which route is being followed, right? All these kinds of things are the matter for network layer. This is what you are going to study in block 3 of this particular course. So how exactly routing is performed, how exactly from various addresses this particular path will flow, what is the ultimate destinations, all these things are dealt with in this particular layer. What are the basic issues dealt with in the network layer? The addressing scheme of networks may differ. You will find this is quite common in networks, and that's why you will find for internetworking, IP addresses, internet protocol addresses have been standardized. Packet size may be different. The frame which you made at data link layer may be different for different protocols. Those kinds of things have to be looked into the network layer. The protocol may differ. Even the basic protocol which is there may differ. One network, for example, LAN may be using a different protocol, CSMA CD or other kind of protocol, and WAN may be using an X.25 or other kind of protocol. Okay. Network layer allows heterogeneous network to be interconnected. Now that is the basic essence. Heterogeneous networks are getting interconnected. Okay. And various terminology you will learn in this particular case. Bridges, routers, gateways, all those kinds of things you will come across. Right? The next layer, the fourth layer is transport layer, which provides reliable, transparent transfer of data between endpoints. All other three previous layers were concerned with not the source and destination, but intermediate source, intermediate destinations. Whereas transport and above layers are basically concerned with the source and the destination pairs, the host to host, and they are not concerned with the intermediate computers or the subnets, communication subnet, which is there. They provide reliable, transparent transfer of data between endpoints. That's why I want to emphasize this particular point. Provides end-to-end error recovery and flow control. So data link layer was doing it for various small intermediate nodes. Here now one particular message may consist of several packets. Now all those packets have reached the destination correctly and have been assembled correctly in the same order. That will be determined, that will be checked by the transport layer, right? Many hosts are multi-programmed. Multiple connections may be entering or leaving each host. So there will be multiple, a particular host may be participating in many different kinds of places or communication subnets or communication situations. So all those things have to be looked into by the transport layer. The next layer which you will find, in fact, one of the key things which you will find in transport layer is that the transmission control protocol, which you fondly know as TCP, sits at this particular level. So this is the transport layer protocol, the TCP. IP is network layer protocol, right? So this you really have to go through your block once again to understand these concepts. But I am just initiating the discussion so that you can understand what is coming next. The next layer happens to be called the session layer. Now the session layer is basically a slightly higher layer than transport layer, and in TCP IP model is basically clubbed with the application layer. What does session layer do? It allows users at different machines to establish a session, establishes, manages and terminates sessions between cooperating applications. Now ideally speaking, some of the applications where we establish sessions, for example, in lots of places, I think in Yahoo also you can establish certain sessions. Now actually they are at application level, but ideally speaking they could have been designed, some of the portions of that could have been designed at session layer level. Presentation layer. Now basically the presentation layer provides independence to the application processes from differences in data representation. You will find many a computer these days talk in terms of ASCII representation. In fact, most of them represent ASCII. But now with the Unicode coming into picture, the data representation of information which is there is not same. How to convert, how to deal with those kinds of problems. It can be combined to the final layer, that is the application layer. And that is what in the TCP/IP reference model has been done. The application layer contains the logic needed to support various user applications. Also provides distributed information services. The basic example, one of the basic example may be file transfer among computers having different file system, having different file naming conventions and different way to represent text file. So this is one simple example of application layer. Now let us look into some of the related concepts which we have discussed in block 3. The first one happens to be the routing algorithms, which is related to the network layer. Congestion control algorithms, once again related to that particular case. Internetworking, already told you that. Multiplexing, using from point to point multiplexing. Addressing, IP addressing. Transmission control protocol, the TCP, and applications. Some of them may be email, World Wide Web, and Telnet. Most of these applications you will be undertaking in this particular course itself. And basic protocols related to it. How exactly they function, like that. How to get the skills of networking? Well, the buzzwords here are read and explore your network. Use of reference material is most desirable. Keep yourself informed with the happenings in the area. In fact, what you are going to find that this particular area is developing very fast. Every day new terms are coming. And Webopedia.com might help you in at least understanding the term, the basic definition of the term. Anyway, you can, there is no limit as far as this area is concerned. You can go to any extent. However, you have to look into other courses also in this particular trimester. The third course in this particular category happens to be the Relational Database Management System. And the basic objectives which we have coupled with this particular course are to introduce the need of database technology. Why do you need it? I'll give you a small brief on that also. To define the basic architecture of RDBMS, you have to go through the basic architecture. In this session, we are not going to define this particular aspect. To design the database system, I might give you some basic hints into this particular objective, and to discuss the issues of database recovery, security, and concurrency control. So what are these issues? We might touch upon some of these aspects. But whenever we talk about database technologies, the first thing we normally need to define is what is a database. And the technical definition for a database system happens to be a database is a collection of persistent data of an enterprise for an application system. So lot many terms have been imbibed into it. Try to understand this language. You are dealing with an enterprise. You are talking about an application system. And what you are meaning by persistence is a data which is stored, which is not lost for quite some time. In addition, the database technology provides centralized control of data of an enterprise. Centralized control probably you are giving too much power to an individual if it is database. But unfortunately, maybe fortunately, it is just an electronic data. So you can get access to lots of information without any ego or other kinds of problems. But a central control of data, central repository of data, from where you can extract whatever you want, gives you a tremendous advantage, tremendous benefits. What can be those benefits? Well, these benefits may be, the first one is sharing of data. You have lots of your data under the control of a DBMS environment. Many people can share their data, and you can even control the access to a typical data to typical users. Controlled sharing rather than calling it simple sharing, right? Reduction of redundancy. Now you have data stored at one place. There is no redundancy of information. Data is at one place. It's one data value. If anybody wants to retrieve it, it will take information from that particular data value. So any change which has to be incorporated, you just incorporate into the database and everybody will get the modified value. Now that's a major asset. Now you might be thinking how good it would be if we don't have different databases one at DLC, one at IGNOU, one at SRE division. If just one distributed database is serving all across, it would have been a tremendous help. Inconsistency can be avoided. Whenever there is a control redundancy, the chances of having inconsistency in data, that is, one address is different from second address, because at one place you updated it, but at second place you could not update it, can be totally eliminated. Integrity can be checked and enforced. The data integrity, the truthfulness of data, the reliance on data, whether whatever data I am getting will be correct, can be enforced, and then you can actually rely on that data. Transactions can be supported. On that particular data, various online transactions can go on simultaneously. Okay, you have a centralized database in railways, multiple transactions goes on at the same time. You basically rely on the database technology. Security can be enforced. Because it is under the control of centralized team, it can be controlled very meticulously. On the other hand, if you see, if you have not done a proper security of it, then it is a major hazard, because data is stored in one place. The bad incident which you remember, which happened on September 11th, databases were there, but they had checked not security, but maybe they had kept in mind the recovery point of view of the database, the redundancy or duplicacy of the database, or tolerance, fault tolerance of the database. And that's how many businesses survived despite a major thing happen, bad thing in fact. So this is security, and the reliability of overall system can be done into this particular situation. Balancing of conflicting risks. But remember one thing, before we go to balancing, remember one thing. The reliability and the recoverability, all these aspects which we will be touching upon, come because there is a redundancy of data. We create controlled redundancy despite having a centralized control. Because we have centralized control, we can easily create and control that redundancy also. So lot many concept I'm trying to tell you. Balancing of conflicting requirements. Two different applications want different kind of indexes. Can be done through a database. Create multiple indexes. Standards can be enforced. Organization-wide, you can enforce lots of standards in that particular scenarios. One of the key aspect which goes with database technology, and one of the key aspect which is most, in fact the most people forget. I've seen many people in the industry and many people in the academic world, but this is the most commonly misunderstood concept of database technologies, and that is called data independence. You must go through this particular concept. I'm just giving you the brief definition here. Data independence is the immunity of applications to change in physical representation and access techniques. This is called physical data independence. The immunity of applications or application programs in case of change in fields to an existing records is called logical data independence. Basically, this is a key advantage of database technology. It provides you powerful tools where you can create unforeseen queries, but this data independence, that a new application can be designed without changing the basic structure of your data, is a very, very powerful thing. Applications can be changed without changing the basic structure of your data. Those basically are some of the basic, and two applications are not dependent on each other at all in that particular context. So go through this particular concept. I think this is one of the fundamentally very important concept to understand in database technologies. The second key concept which you will undertake in this particular course, the database management system course, is database design. Now what are the issues related to database design? The first, in fact, foremost is the entity relationship diagrams, the integrity constraint, the normalized tables, and design of structured predefined queries or applications. Entity relationship diagram, in fact, is a system modeling tool and very useful where you are using database oriented systems. In fact, this tool gives you raw table design, the basic tables which should be used. You must exploit this particular concept to a great extent. Try to follow the basics of these and you will be able to, what is an entity, what's a relationship, how they are converted into tables. If you can master this, you will be able to master quite a lot of good design principles and practices along with. The second issue is, what is integrity? Well, as I already defined, accuracy or correctness of data in the database. Define the rules. Define how a data given in one table is linked to data related to other table. The referential integrity. That's going to be a very good concept to understand. The third concept over there will be normalize the table. Normalization. What is normalization? It is an attempt to eliminate, minimize the problems occurring due to data redundancy over the lifetime of database. It is an attempt for good database design using decomposition. So you just want to minimize the redundancy. Where exactly the redundancy is? Within the table. those kinds of redundancies may be there. For example, if I'm keeping the records of your grades, so if I keep my database as name, enrollment number, address of the student, course CST 101 or course name and marks. So for each course I need to repeat all that particular information. That's a redundant design, right? That is redundancy. And normalization sees to it that we break this table into one student information, that is name, enrollment number, address, and then second the enrollment number, course code and marks. That kind of information. There will still be some information repeated, but it is not redundant, because if I say enrollment number 98, some enrollment number, course CST 101, grade is A, then second information for the same enrollment number will be for a different course. So this is not redundant information. This is different information being represented. So normalization is an attempt to break the table into the tables where the information is not represented in redundant form. The next issue which we would like to talk about, the database technology, and which is basically dealt. So these, in fact, whatever we have discussed till database design is covered in block 1 and 2 of this particular course. The third course, basically, the third block deals with security, recovery and concurrency control. Now what are the basic issues in security? Security basically is protecting the data against unauthorized disclosures, alteration or destruction. Giving certain privileges in a relation to certain users, views, database views, which you will be learning very soon, basically availing some basic information to particular user in database system provide automatic security of hidden data. In fact, what you will find, security as a concept is a major concept. Security you can do at operating system level, at the database management system level, and further on at the application level in the form of views. Making available the data to users of various type, only specific data. Okay? So security definitely deals with those kinds of aspects or issues. Recovery deals with restoring to the database to a state that is known to be correct or consistent, satisfying all integrity constraints. A failure might have resulted into inconsistent state of database. So what you may have, if you want to recover, now what can happen? You are working with the database system and suddenly there is a failure of electricity. You must have seen this particular kind of situation with your Microsoft Word. That you are working, you are typing some information and suddenly there is a failure. What happens? When the light comes back again, then you get some recovered file. Had it been a very old version of Microsoft Word, recovery is not there. Now that's a form of recovery. However, in most of the cases what you will find, you might not get the most current form of data which you were editing. In database technologies you don't compromise till that point. So you need to have even greater need of recovery. Right? So this is going to be very interesting and very good topic to understand at this level and go through this. Recovery is provided generally in a large multi-user shared database environment. Very little or no support for recovery is available for small single-user non-shared databases like Access. In small databases, ideal mechanism is to create periodic backup copies. So if you are dealing with recovery and you really have to look into, you are dealing with very small system and databases, you got to design your own recovery mechanisms. And the best recovery mechanism is use periodic backups. So in case of any failure, like what happened in the case of disaster, you can recover the data without any problem. Databases such as Oracle does provide automatic recovery, just like what Microsoft Word do. However, what you must keep track that all recovery is based on redundancy of information. May not be in a fully replicated version that you just copy the database in the form of backup. That's a physical way of doing it. But in database technologies, it might be done by backing up only or recording only the changes and then recording the previous state, backing up the previous state and keeping it somewhere. And all the changes are getting recorded. So something of that kind. Concurrency. Now, access of the database by more than one transactions users at the same instant of time falls under concurrence or concurrency related problems. Concurrency control removes unwanted results. Now, what do I mean by concurrency? I simply mean a very simple thing. You are dealing with railway reservation system and there are multiple people trying to book onto the same train, right? By chance, two people try to book at the very instant of time and both are wanting to book from the same place to same destination and both got the same seat. That's a concurrency related problem, right? But it doesn't happen. That means the reservation system has already taken care of the concurrency related problem. How simply that particular thing can be achieved? Probably by a simple mechanism called locking. As soon as obviously somebody will try to attempt the thing first in the computer because it's a serial execution device, or after all the seat is one. So one person will come and try to book it in the internal sense. Maybe externally both have tried at the same time. So that is the time one will get hold of the resources. One will get access first. And what will be done along for that? Locking is a mechanism to maintain transaction integrity during concurrency. Lock the other object out. So I got the resources first. I lock the other people out at that same time. If two people try to lock at the same time, that cannot happen. That mechanism is inbuilt. So that is the way you avoid the concurrency related problem. But wherever there is a locking, the immediate problem will be deadlock. What is deadlock? It is a situation in which a group of transactions are in simultaneous wait state, each of them waiting for one of the other transaction in the group to release a locked resource before it can proceed. In a nutshell, both the transactions cannot proceed because they are waiting for a resource which is being locked by each other, and that is the problem situation, deadlock. None of them can proceed. Okay, so that kind of a problem. Wherever you have these kinds of things, for example, normalization, you pay penalty by breaking into two or more tables. And whenever the query is to be answered, those two tables are to be joined together to answer a query. So you pay penalty in the form of a bit of performance. Now what skills which are to be developed in this particular course? designing of a database system, creation of tables, creation of integrity constraints on tables, and creation of queries, forms, and reports. So these are some of the basic skills which you need to develop in this particular course. How to do it once again? Solve as many problems as you can, coordinate theory and practice, assignments should be undertaken individually, references should be explored, try to refer to more references as the technology has progressed further, and it is going on and on. So this is what you have to do in course 3. The final course is Advanced Topics in Software Engineering, and the basic objectives relating to this particular course is to describe the concept of software process, to discuss the issues relating to software process management, project planning and controlling, and to discuss the umbrella activities relating to software project. So these are some of the basic issues which are there in software engineering. Again, the skills required will be that you control those things through, you design and develop a software system. Finally, let us have some helpful tips. You must put efforts in your studies. Very helpful tip. Do lot of problem solving. Come prepared for discussions and practical sessions. Submit assignments as per schedule. Remember, following a good process for software development produces good software. So must pay lot of emphasis to the course of software engineering too. With this, I come to the end of this particular session. If you want to contact us for any of the academic queries, the contact point is adit@ignou.ac.in. For the time being, bye from